Again, welcome. This is Joanna Riegel from KMJ Consulting, and on behalf of the I-95 Carter Coalition, we would like to welcome you to the RITIS and Probe Data Analytics Suite user group this morning. Going to get started now. The call-in number will be in the chat box for your reference. Participants are in listen-only mode. If you do have any difficulty with the audio, you can press *0 to speak with an operator. If you are having any trouble with either the web or the audio or any questions, you can reach out to Wayne Gibson, and his number is provided, 609-970-2584. That's his mobile number, and you can reach in there. As you heard, this webinar is being recorded, and the presentations will be posted to the Coalition's website. All participants will receive a link to the presentation after the presentations after they are posted. Because all of our participants are in listen-only mode, we're going to be using the chat box today for your questions. If your question is directed to a specific person, if you can note that, that's helpful. And those questions will be monitored throughout the entire webinar. Questions may be answered at the end of the presentation or at the end of the webinar, or depending, we have a really busy agenda today, and they may be answered during the other presentations. I'm going to turn it over to Jesse Burke from the Delaware Valley Regional Planning Commission. Jesse is one of our user group co-chairs along with Kelly Wells, and we're happy to have both of them today on the call. At this point, Jesse is going to host the meeting.
Thanks, Joanna. Welcome, everyone, to this meeting of the RITIS PDA Suite user group, and happy Valentine's Day. Just want to thank everyone for participating today. As always, we have really great representation all up and down the I-95 corridor. Just want to walk up, and here we see some of the folks that are participating today. Just want to walk through the agenda. As always, we have a lot to cover, some really great presentations here. We've got some probe validation findings from 2018, presentation on using RITIS for improved operational awareness via video wall. I think that's a really interesting one. Also had a presentation on using RITIS to help implement arterial performance measures. Then we'll get some updates on the various working groups that have been started recently, also the EDC for TIM dashboards, and as usual, Michael Pack will walk through some of the features that have recently been added to RITIS in the PDA suite and also what's on the horizon. And finally, we'll end with some agency input, and as Joanna said, hopefully we'll get to do some Q&A throughout, but if not, we'll try to get it at the end there. So next, just want to introduce you to all of our various speakers today. You know Denise, you know Michael Pack, and I think you know Mark pretty well at this point. Very happy to have some other presenters with us today. Zach Vander is a faculty research assistant at the Center for Advanced Transportation Technology at the University of Maryland, and he manages the probe data validation programs for the I-95 Corridor Coalition Vehicle Probe Project, as well as the National Performance Management Research Dataset. Also happy to have Daniel Smith with us today. Daniel currently serves as the Florida DOT District 4 ITS Operations Manager and has served in the past as the District 4 ITS Design and Deployment Manager. Daniel holds a BS in Electrical Engineering from Florida Atlantic University, and he's a veteran of the U.S. Armed Services and has been a member of both the U.S. Air Force and U.S. Coast Guard. And finally, today we have Elio Espino, Senior Project Manager. Elio is the Traffic Engineering and Transportation Planning Department Head at A&P Consulting Transportation Engineers Incorporated. A&P has more than 21 years, Elio has more than 21 years of industry experience. Early in his career, he worked at Florida DOT District 4, where Daniel Smith works now, focusing on highway safety improvement programs. And Mr. Espino is also part of the district-wide signal retiming contract with the District 6 Traffic Operations Office and works closely with District 6 Traffic Operations staff to develop the first active work zone management program, which has successfully reduced traffic delays on several projects. So those are our speakers for today. With that, I'll turn it over to Denise to give a few more updates before we get into the presentation. Denise?
Thanks, Jesse. We have a lot to cover, so I'm going to be brief. I do want to thank all of the speakers, though, before we begin. There's an incredible amount of data being presented today, and I want to thank them for their hard work and prep. The Coalition is always proud to sponsor these user group meetings. The slide, there should be a slide coming up, a next slide. There we go. And this is just a brief summary of the work, or the meetings that we've had to date. We've had a CAB webinar. Let me go back. There we go. We've had a CAB webinar. It showcased some of our member state roadmaps. We also had discussion of a capacity maturity model, how that might work for states working on their CAV programs, connected automated vehicle, for those of you that may not know that. We had a heavy towing in-person peer exchange where best practices in like the heavy towing industry related to incident management, that took place in New Jersey in November. It was attended by representatives from state agencies and law enforcement in the towing industry, and there were 5 states that actually were in attendance there. In December, there was a really interesting origin destination webinar. I hope some of you were able to catch that. We introduced 2 new data sets, an origin destination data set and trajectory data, discussion about that. We explored a national OD study, and we discussed some emerging TISMO and planning apps leveraging these data sets. All this information is on our website. There's slides, there's audio available in case you missed it. If you can't find it, shoot me an email. I'll be glad to show you where it is. In the upcoming category, we've got 2 meetings that are going to be held in Philly on March 6th and 7th. The first one is an invitation only. It's a planning session. We look to define the topics and develop a calendar for our fiscal year 2020. So if you have any ideas on topics of webinars that you'd like to see or exchanges, please, again, feel free to email me so that we can get that into the discussion. On March 7th, that's our annual traveler information meeting. The topic this year is going to be getting the word out to the public during emergency operations, and the presentations are going to be from Florida, North Carolina, Pennsylvania, and Texas, and they're going to center on the significant weather events of Irma and Harvey and Michael and Florence, all hurricanes, and then some major snow events. So that should be really interesting for the Travel Info folks and anyone else interested. Lastly, in March, we're going to be holding a webinar on drones. We're going to showcase the programs of Mass DOT in Delaware. And they're going to focus on the actual development of the program, how they got to where they were. And then we're going to follow up with an operational workshop in New England that's actually going to be talking about, I've got the drone, how do I use it? And those are going to be use case scenarios and actual demos in the field. So as you can see, a lot going on. With that being said, I'd like to turn it over, I believe, to Zach, who's going to talk about probe data and the validation program.
Yeah, thanks, Denise, and good morning to everyone. As she said, I'm going to be providing a brief update on the work we've been doing to validate the speed and travel time data that's available in the PDA suite. Actually, though, before I jump into the validation-specific content, I just want to start by giving some context for the Vehicle Probe project itself. So the Vehicle Probe project, also known as VPP, started back in 2008, and its purpose is to provide I-95 Corridor Coalition member agencies with reliable network-wide speed and travel time data. And the idea here is to do so without requiring agencies to go out and deploy a ton of sensors. So the original project started with a single vendor, which was INRIX, providing the probe data. And as part of the program, the University of Maryland was involved with the validation effort. More recently, the project has progressed into a second phase called VPP2, and 2 additional vendors here in TomTom have been added, creating a type of traffic data marketplace. So in this current iteration of the project, member agencies are able to choose the data provider that best meets their needs, but University of Maryland is validating data from all 3 of them to ensure that they're staying within the contract specifications. So just for reference, we currently have 8 member states. 7 of them are all in. 1 of them has partial coverage on their road network, and and we have probe data on over 9,000 freeway miles and 79,000 arterial ones. So with that as a backdrop, I'll jump into the validation content now. So as I mentioned, University of Maryland is the party that's responsible for regularly validating the probe data from all three vendors to try to ensure that it adheres to the error tolerances that are set in the contract specs. So how do we do this? Well, we go out and collect our own ground truth data sets, and then we use those independent data sets as a way to evaluate the probe data. And the way we do this is we go out and we deploy sensors along the side of road segments of interest, and we collect ground truth travel times through re-identification technology. So these sensors are able to detect vehicles, or more accurately, electronic devices in vehicles, passing the sensors, and then sensors down the road later re-identify those devices and allow us to directly measure the travel time. So we like this approach, this re-identification approach, because it allows us to quantify the ground truth speeds over a distance, so the space mean speeds, which help facilitate more accurate comparisons with the probe data as compared to measuring the speed at a single location. So this validation process is something we've been doing for quite a while. In total, we've put out more than 60 reports since the beginning of VPP1. So this is a process that's evolved over the last few years. I have a slide here that just lays out the major steps in the validation process. I realize not everyone is aware of what exactly we do when we perform the validation. So just at a very high level, we start by deciding where we're going to collect ground truth data, and we rotate through different member states who are participating in this process. And so we start by having a dialogue with the member state. We try to figure out locations, certain road segments that are of interest, both at a high level to us from a validation program level perspective, but also to the member agency. So we want to provide value for everyone. And this is an iterative conversation that often involves local jurisdictions and various parties, but eventually we decide where we want to collect the data. Then the next step is to go out and actually collect the data. In the beginning of the project, this is something that University of Maryland did ourselves. More recently, we've been contracting with a company that handles the logistics of that process. But in any case, they go out and collect the data where we've decided we want it. And then when the data comes back, we start processing it and manipulate it to extract some insight about what's going on these road segments. And we make sure that the data is high quality enough to be able to truly characterize the speeds during the duration of the study. So once we're confident that we have good ground truth data, then we ask all three probe vendors for data on these same road segments. And once they provide the data to us, we conduct some standard analyses to make sure they're within contract specs and to draw some insight from what they're reporting. And then this culminates in us producing a final report, which we then publish on the coalition website. And in a future slide, I'll link to where you can find those reports. So again, there are a lot more details, but keeping kind of a high-level view here, I think that gives sufficient context. So as we talk about comparing the vendor data to our ground truth data that we collect, I think it's helpful to build an intuition for what this data looks like. So here on this slide, I've put a plot of the speeds on a particular road segment from a recent validation over a 24-hour period. So we again have two key data sources. We have the vendor data, which in this plot is in red. So also in this plot, the y-axis represents the speeds. In case you can't see, the speeds are on the y-axis, the time is on the x-axis, and the little red dots represent the speeds that the vendor is reporting over the course of the day. Then additionally, we have our ground truth data sources, and these are represented by these faint light blue X's. So you can see we have a lot of these ground truth observations, and they have some, they vary. There are multiple per time period, but in general, these are the two data sources we have. To actually do a comparison between the ground truth and the vendor data, we need to do some aggregation of the ground truth to make sure we're confident that it accurately reflects what's going on the road. So for each time period, we take the average ground truth speed, and we also look at we build a confidence interval for the true ground truth speed. And so these are represented on this plot here by the average speed or the mean speed is in the solid black, and then we have the confidence interval in the light dotted black lines. So anyway, I think this is kind of helpful to see what's actually happening in terms of speeds for a sample plot. One other thing I want to point out is here, we're also interested in looking at what happens when the speed drops drastically. So when there's a slowdown event. So here we can see that the vendor data indicated by the red dots, captures this trend when the ground truth data shows a sharp reduction in speed. So this is more qualitatively looking at things here, but I hope that helps build an intuition for the data we're working with. So now, in the remaining minute or two I just want to talk about the validation work we've done this past year in 2018, and then the upcoming work we're planning to do in 2019. So in 2018, we produced 4 validation reports based on data collections in Georgia, New Jersey, Maryland, and North Carolina. And so the table at the top of this slide summarizes some of the relevant information about these reports, which you can check out here. But I do want to point out a few things. So first of all, if you look at the road type column here, you can see that most of these 3 out of the 4 validations were on arterial road segments, and this is intentional. So if we think about the beginning of this project, way back in 08, 09, was exclusively dedicated to freeways, and over time we've gotten more confident in the quality of probe data on freeways, and so we've been working primarily with more challenging situations. And so that's something that we're going to continue focusing on in the future as well. So I want to point that out. In terms of the data quality, we have found that all 3 vendors are producing quite reliable data. Over these past 4 validations in 2018, the error metrics were very strong for all 3 vendors. It's kind of hard to summarize all the error metrics here on a slide, so I'd encourage anyone who's interested to go out and check out the reports. There's a link at the bottom of the slide. We calculate quite a few metrics for each validation, and those are contained in the reports. But at a very high level, it's very, very rare for any of the vendors to be out of spec on any of the error metrics in any speed bin. So it was quite strong performance this past year. And then finally, I want to point out again, or reemphasize, that we've been trying to choose locations that serve dual purposes. First and foremost, we want to collect meaningful data for the validation program, but where possible, we also want to choose locations where we can collect high-quality ground truth data that the member states can use themselves. So some examples of this are choosing to do a study on a particular road that's getting some signals retimed. That can provide an interesting before and after data set. In North Carolina, we chose a location that was that had a parallel corridor nearby, and so that helped lead to a separate report we did, kind of investigating some travel behavior between those two corridors, and I think was a pretty interesting analysis. Moving forward, we're also looking at data on an important freight corridor and also choosing time periods that align with holiday travel. So these are some examples of how these data sets can be valuable in multiple ways. So as we move to 2019, we're continuing to focus on arterials, and we're also working to try to streamline the process to be able to produce the reports in a more timely fashion over the course of the year. We're producing 4 reports. 3 of them are going to be traditional ones where we go out and collect data and produce a report based on that data set. But the final one is going to be an arterial report, which is going to look at the trends in the data quality on arterials over the past few years. And so my final slide here just contains a bit more information about this. The motivation for this report is that an original one was first published in 2015, was very well received, and it looked at the probe data quality on arterials over a number of years. At that point, there was only one probe vendor, but now that a few years have passed and we have a couple more probe vendors, there's been interest in creating an updated version of that report to see how the trends have changed over the last few years. So this is going to replace one of our standard validations, and yeah, stay tuned. That'll be published this year and should contain some additional insight that will be useful. And so with that, I think that's all I have from a validation perspective. I'll turn it back over, and I think either to Jesse or Denise. We'll see if we want to take questions now, or maybe I'll check out the chat pod if not, and answer them in there. Our contact information's here if anybody has any further questions about validation offline. Thank you.
Thanks, Zach. Really appreciate the presentation. I think, the validation reports that you're doing are really one of the key things that, makes the vehicle probe project so great, having that transparency. So I think that we're going to keep moving at this point, a little bit behind schedule, so we're going to maybe, if any questions come in through the chat pod, you can maybe tackle them there, and if not, we'll try to get to them at the end. I think all of our technical issues are resolved, Joanna, is that right?
I believe so.
Okay,
you can
good.
certainly, yeah.
Good. I think
reach out to a chat. Yeah, sorry about that. Only for some folks, the lucky ones, I guess. So if you do, you can certainly chat with the presenters or the host, and we're more than happy to try to address your issues.
Great. Thanks, Joanna. So with that, I think we'll move on to Daniel Smith's presentation on the dynamic video wall. Dan?
Good morning, everybody. Please forgive me in advance if you hear me cough or you hear an unexpected mute. There's a little bit of a cold going around here. I'm going to move right into the first slide. I'm from District 4, which is Southeast Florida. Contains five counties: Broward, Palm Beach, Martin, St. Lucie. And I'm going to go into the slides, you're going to see we sort of separate everything into 3 separate geographical areas. The metropolitan areas around Fort Lauderdale, metropolitan areas around West Palm Beach, and the northern 3 parts of our counties in our district are mostly rural. So with that said, what you see here is our District 4 Regional Transportation Management Center. We've been open almost 15 years, staffed 24 hours a day, 7 days a week. We haven't missed a minute since we opened the door. I think we use our video wall in a different way than I think a lot of TMCs. In the background of doing this way, by putting information and performance measures and dashboards on our video wall, started probably about 5 years ago. And I realized that we could not tell our operators every single step for every single scenario. So we started something called an Operations Academy, where we'd teach our operators traffic engineering principles. We'd have our traffic engineers come and speak to them. We'd have them look to the METCD. We'd have college professors come and discuss civil engineering, traffic-related things with them so they could make informed decisions as, freeway managers and arterial managers. And by doing that, I realized that they also need to know why we do what we do. And this is where these performance measures come in. Over here on the left side of the wall, I want the operators to be able to know what's happening at any given moment. This is all real-time information that I'm going to go through on here. And why they're doing what they're doing and how it affects traffic, how it affects the people, how it affects money, everything that is the background of a TMC operation. I'm going to go forward one slide and then come back to this one because you can't see what's on the walls on the left and right side of the TMC, which is interesting, which I'll get to in a little bit. These are speed profiles, which I'm going to come back to. So our TMC is essentially separated into four main sections. The people on the left side over here are mostly responsible for I-95 and I-75. People you see on this side over here are operating our 595 express lanes, which are also reversible lanes. It goes eastbound in the morning and westbound in the afternoon. People in front of here are doing our arterial operations, which is mostly in the major metropolitan areas. The people in front, we share our building with Broward County Traffic Engineering, so these are the signal timing engineers sit over in this area here. What you're seeing here is a speed profile of I-75 and the entire length of I-75 through our district. The next one, this is I-95, and it's actually, I think, about 200 miles of I-95. And what you're seeing on this is the average speed updated every 20 seconds with a rolling 1-minute average. So we can actually have real-time information about the average speed of the entire length of I-95 in Southeast Florida. A lot of people have found this very interesting. If anybody has any questions or wants to know this, you can type in the chat box because somebody's actually here with me that can respond, or any questions you have, you can feel free to contact me after this. Here's some facts about the video wall. It's actually fairly new. And barcode software is going to become important when I get to the next part of my presentation. So these are some of the performance measures that we look at real time. Right here is the amount of incidents happening at any given moment. Again, real time. What you see here in this center part of this is the number and type of incidents calendar year to date. We broke 100,000 incidents for the first time ever last year in our district. That includes everything from crashes to car fires, rapid incident scene clearance activations, anything that creates an event in our system. What you see here is the amount of devices that are not available for use for operations. Again, real time. When operations opens a trouble ticket for maintenance, only operations can close that ticket. Down here is sort of our bread and butter. It's our incident clearance time. Again, this is Broward County, Palm Beach County, and the northern 3 counties. So we measure them differently because they have different characteristics. 53 minutes is actually pretty good. If the needle's in the green, we're doing better than we did last year. If it's in the orange part, we're not as good as we were last year, but we're still within the 90-minute time frame of the Florida Open Roads policy. So this is actually taken about a week ago. What you see here is 595 Express. This is real time again. It shows the toll that's being charged at the moment and the directional flow of traffic. And as well as these red lines you see here are physical barriers to prevent wrong-way entries and when we would change directions of travel. When you see a white line over here, it's a geometric way to prevent the traffic from entering the wrong direction. This is the generator system that we have in District 4. Everything that we have on the freeway, or any freeway, is backed up by generators. We have a 600-volt power distribution system that runs underground the conduits that are next to the fiber optic cables. And the reason we have to have this is now we have full redundant power. We've got UPSs in most of the cabinets, so if we lose commercial power, UPSs will take over for 3 minutes, the generator starts up, and we never miss a beat. So we need to know the status of the generator. I won't go into all the details, but all green means they're standby, ready to go. White means is usually a minor thing, maybe low on gas, or a minor thing that's not going to affect the operation. So in this picture, everything is good. This is our fiber optic network. Again, spanning the five districts. And this is actually presented by a piece of software called SolarWinds, which sort of pings almost every single device on the network at all times. And we use this to know if we get a fiber strike, somebody hits our fiber somewhere, which happens fairly often, we need to know about it immediately. What you see over here is obviously RITIS. And we sort of usually keep this up in different parts where we know we've got a lot of congestion or something's going on in the city, which I'm going to get to, I believe, in the next slide. This is an interesting slide because in the center of the video wall, we allow the operators to put whatever's going on at that moment of interest. And you can see this fire truck just barely in this image, but what happened is they were doing a directional bore in a major part of the center of Fort Lauderdale, and they hit a 6-inch natural gas line, which closed this intersection for almost 14 hours. And you can see the effects of this because this intersection is right about here. So we see the way the traffic starts to just build up around the entire thing, and then our signal engineers who are sitting here, or the officers who are on the right, can actually see in real time any signal changes that need to be made, or we're looking at, bottlenecks in real time or just congestion in real time. The barcode system that we use for this video wall allows us to change what the video looks like instantaneously. We can create any number of layouts of this video wall that you want to see. We could put nothing but video on there, hundreds and hundreds and hundreds of camera images all at the same time, but that's of no use to anyone. So we can go into something we call like a hurricane mode. We're putting the weather channel on there, live Doppler radar, we'd be logged into the EOC, and so all we have to do is IT just switches that. We just change the entire look of the video wall. Or we can even make it one giant image if we need to. So there's different ways that we use the dynamic ability of the video wall itself to improve operational awareness. And I just want to touch on something that we're in the process of creating now, which I think is a big benefit to the way that we respond to incidents on the freeways and the arterials, is we found a way to essentially broadcast anything that we can put on the video wall, almost like Netflix or a YouTube stream. And the reason we want to do that is for first responders, because we communicate with a lot of first responders, we have a lot of incidents. We want them to be able to see what we want. So if there's a crash, and I know this certain fire department responds to this section of I-95, I can drop the image of that crash onto their video wall, onto a monitor that's in their building somewhere. And that is the end of my presentation. Again, any questions, feel free to ask or contact me via email. Thank you.
Thanks, Dan. Really great presentation. Really interesting. Love to hear at some point what other folks are doing, if anyone else is doing anything like this. But I think in the interest of time, we will move on to the next presentation at this point. We've got a couple questions coming in through the chat pod, and it looks like those are being addressed. But if anyone else has additional questions for anyone that's presented so far, feel free to enter those into the chat. So next, we'll move on to Elio Espino's presentation. Just want to remind everyone, if you haven't gone to full screen at this point, there's a little button to do that. I would recommend doing it for this presentation just so you can see some of the graphics and get the details a little bit better. So with that, I'll turn it over to Elio.
Thank you.
I'm sorry, before we go to Elio, we'd like to actually ask a question. So at this point, we're going to open up a poll for everyone. And what we're looking for you to do is to answer the question, what type of information are you showing on your video wall? And you may select more than one response. Okay, it looks like folks have finished responding and you can all see the results, we're going to end that poll and close it. Thank you so much. And we'll move over to Elio. Thank you, Elio.
Thank you. We started using RITIS in 2015, and basically it was for a signal retiming project. There was a need to be able to assess before and after conditions, and also to identify some of the deficiencies. We also, and I'll go over that. We also have been using RITIS, the RITIS interface, for monitoring corridors and to get travel time reliability, to basically get some of the arterial performance measures, and also quite extensively for MOT, maintenance of traffic, to be able to assess the performance of a construction zone and be able to make changes to improve mobility and safety during construction. On this slide, on the upper right-hand corner, basically, the challenge with the signal retiming program, especially in the Miami-Dade metropolitan area, it's highly congested. So, and we wanted to be able to evaluate what would be the best approach to improve mobility. And there was also a budget constraint in terms of how much time and effort and resources we were going to be able to spend on the signal timing. So basically, one of the ideas that we had was to, using the RITIS interface, be able to look at the travel time patterns and overlay them with the signal timing plans, the existing signal timing plans. And we did this for a major corridor, which is US 1. It's very congested. So what you see on the top of the slide, it's basically the different time of day plans, and on the bottom you can see the before and after conditions. In this case, we realized that there was an assumption made that 7 to 9 was the peak period, and 4 to 6 was the peak period. However, by looking at RITIS, we realized that the peak periods on US 1 extended beyond 9 a.m. and extended beyond 6 p.m. And so when you look at the before condition, you can see the difference in travel times, the extent of the peak period. And on the after condition, after it was recommended to add an additional timing plan, we were able to reduce travel times, but also we were able to reduce the impact of congestion by about an hour, which was very significant. So in this we were able to do by using the RITIS interface. So, and since then we have continued to also look at a reduction of peak period as a performance measured when doing signal retiming work. Also, another feature that we used, and going back to the periods of congestion, and in a highly congested area like Miami-Dade County, a lot of the issues are, how long does congestion last? And if you can see here on the top the before condition, and we use the congestion maps from RITIS, and look at, we're able to show that by making changes to the signal timing, we were able to improve mobility. And this tool was very useful to graphically depict the benefits just beyond the travel times. We've also used RITIS to assess the performance of adaptive system. And in fact, Miami-Dade County is now going through a very aggressive APMS project. And there has been multiple quarters, around 12 critical quarters in the county, in which adaptive signal control has been implemented. And basically, we have provided support and continue to provide support in assessing the benefits of the adaptive system. And this is from one of our local papers in which it shows some of the benefits, anywhere from 11.5% in travel time reductions. And also, it actually mentions by name the RITIS as the tool that was used to be able to assess performance. And we feel it's a very useful tool for us in doing this type of work. In addition to adaptive and signal timing, we've also used it, as I mentioned before, for construction zone assessment. And basically, we have used the data to compare the before and after conditions. And this is key for a lot of the local agencies and the FPOT. When the project is in construction, the department gets a significant volume of complaints, and basically the department has taken the approach of managing the work zone and making changes to the signal timing, and this is showing the before and after conditions. And so we have been able to develop dashboards using RITIS to be able to show how the construction zone is performing. With arterial performance measures, we are currently moving into evaluate in more detail different users. So basically establish a program in which quarters are evaluated based on different types of users and identifying what is the appropriate performance measure for each of the users, which is basically what we are describing here. And through that monitoring of the performance, be able to make changes and be able to assess how those changes are performing. So, for instance, we're showing here the Florida Department of Transportation has recently adopted the context-sensitive functional classification. So, going back to the same US1 quarter, we see that there are different conditions. It's a long quarter, but you have different characteristics. So we are developing performance measures depending on the characteristics of the quarter. And in some locations with, for instance, near the University of Miami, pedestrian activity, this is the area where we have the metro rail station. There's a need for accessibility to the metro rail station. So other modes also need to be taken into account when doing the performance measures. And that's what we're going through now. And we are currently developing this daily performance measure along the US1 quarter, in which we are comparing previous weeks to the current day. And we are all of these different graphics are showing different times of day, and that's matched by the timing plan, or not only the timing plan, but similar travel time characteristics, for particular periods. So in this case, we're also logging incidents and construction activities and complaints from the public. But this we're using the RITIS interface to be able to obtain this graphics. And this is for monthly, showing the monthly performance measures. So we are generating multiple dashboards for the quarter. Moving forward, like I said, we are looking in more detail at how we can get single performance measures or using RITIS to be able to assess signal performance, also evaluating special operations such as transit signal operation, transit signal priorities. That's a big effort now in Miami-Dade County. So we're also trying to develop dashboards and performance measures for transit. And that's the end of the presentation. I'll be happy to answer any questions or at the end. Thank you.
Great. Thank you, Elio. Definitely some interesting applications, and I think it feeds into some of the updates that we'll be hearing next, particularly some of the updates that Michael's going to cover. Looks like at this point we've got a bunch of questions in the chat pod, but I think they've been answered at this point, so definitely encourage anyone else, if you have questions for Elio, Dan, or Zach, go ahead and enter those into the chat pod. Otherwise, I think we will keep moving. Move on to working group updates from Mark Franz.
Mark, are you with us? You may be muted. Michael, would you like to move forward and then we can go back to Mark's, or do you just want to speak for Mark today?
I will speak for Mark. We had a trajectory analytics and origin destination analytics working group yesterday, February 13th, around 1 o'clock. We had good participation from about 20 different agencies on that. It's just the first of many follow-up working groups where we just kind of presented the initial information. But it was a good meeting, I think. We have 2 more coming up very soon. Our signal performance measures working group is February 26th, and then our enhanced work zone analytics working group is the 28th. Again, these working groups are meant to give agencies the ability to tell us what it is that you need out of our tools. What do you like? What don't you like? What's missing? What do you wish you could have? And to give us feedback on designs and even to vote on which features we ought to prioritize over others. If you are interested in joining one of these working groups, you can send me an email or Mark Franz an email, and we'll put you on the list. There are 2 other working groups that will be starting soon, but haven't yet. One is a transit analytics working group, and the other is Transportation Disruption and Disaster Statistics Steering Committee. This is something that is a relatively new project funded by the Bureau of Transportation Statistics, and the I-95 Corridor Coalition is leading this effort. So again, if you've got any interest, just send us an email. Otherwise, I'm going to then move on and start talking about the RITIS and probe data analytics recent updates and then what is in the works. So we've been pretty busy since our last meeting. Some new deployments and development include an everyday counts incident clearance and roadway clearance time tool. We've updated our radio player feeds for a new API, and we've fixed a bunch of different bugs. We've made the CCTV player now be able to show static images that are only refreshed like once a minute or once every 5 minutes for agencies that don't have streaming video. And we've integrated some other agencies' data, including Illinois and Missouri, and we've made significant improvements to our trajectory analytics tools. What I'd like to do real quick is go in and show a demo of this everyday counts tool so that everyone understands what they're about to have access to. Give me just a second to share my screen. All right, I'm assuming everyone can now see a screen that has a map on it, and now I'm moving moving over to another tab. Someone needs to tell me if they don't see that. This Everyday Counts tool allows you to go in and look at all of the different agencies that are providing incident, event, and work zone data to us. And you can go in and you can choose one or more. I'm going to start with Maryland. I'll add Virginia on there as well. And then we can go in and we can see all the different event and incident types that exist in each of these systems. And I could query just a couple of them. I could look at the standardized types. We take every agency's data and we standardize it so they all have similar definitions. We also have the Everyday Counts approved event types. We could choose those as well. And we could go down and we could search for a particular road, particular region. I am just going to go in and do a query looking at like the last 7 days or so and submit that. And it'll take a minute or so to go and grab all of that data and bring it back. Give it just a second. Here we go. So it's telling me for the last week in Maryland and Virginia, there were 4,285 events. And all of them are listed here in this big table. They're listed by agency, by type, by start time, close time, location, which operations center managed them, because some agencies have multiple operations center, the duration of the event, how many operator notes were typed out, how many responders were involved, how many lanes were closed. You can sort this table by going in and clicking on the headers and find the ones that had the most responders or the ones that lasted the longest. Then there's buttons over on the left that allow you to go in and, for example, bring up the incident timeline for those particular events. But then we also have these little buttons up on the top. I'm just looking at a list right now, but I want to go in and look at some statistics for these agencies. So starting out, we're just seeing a bar chart that tells us how many of each type of event were managed by each agency. So the blue is Maryland, green is VDOT. You can see how many disabled vehicles there were versus collisions, traffic congestion, construction work, so on and so forth. I can look at the Everyday Counts approved incident types and how many there were. I can look at how many incidents there were by hour of day. I can look at the Everyday Counts incident clearance time stats. So how many incidents cleared between 0 and 30 minutes, 30 to 60 minutes, greater than 2 hours. You can do the Everyday Counts roadway clearance times and do that as well. And you can also look at them by county, by road, all sorts of different ways to slice and dice the data. And then there's a map view as well that you can click, and that then generates a heat map showing you where these incidents are most likely to occur or have occurred over the last 7 days or so. And if you don't like the heat map view, you can switch over to individual event icons. And there's all sorts of other things you can do with this as well. You can go back and you can sort these. So maybe I only care about disabled vehicles. I type the word disabled there. And then when I jump back to the bar chart, now I'm going to get stats only for the disabled vehicles. Or I could go in and type collisions, and I'd only see the stats for the collision data. There's different ways to slice and dice the data, and then the map will then also only show you the disabled vehicles as well. So this tool we just finished up last week, and it's going to be deployed to the RITIS website next week or the week after we finish a little bit more QA work on it, just to make sure there aren't any significant bugs. So that's that. Let's stop sharing my screen now and go back to the slide deck, please. All right. So let's now talk about some probe data analytics deployments. So we've been fixing a lot of bugs that you all identify and email into us. There's some issues with Map 21 tools where we were swapping some colors on the side of the roadway. UDC reports now save your preferred volume data provider from your prior sessions. They weren't doing that before then. And there were some other crash and performance summary things we fixed, including trend map exports to video files. The particular video file that we exported them to in the past wouldn't play on as many systems and players as we would like, so we've now updated that, and a few other bug fixes. But there have been significantly more new feature developments that we've been working on and deploying. The first is related to INRIX XD data. That's the finer granularity data that INRIX provides, smaller segment links. INRIX XDs are now available in the congestion scan tool, in performance summaries, and in performance charts. Now, it's only going to be available for agencies that are, actively ingesting that data, which right now is Michigan and Pennsylvania, and now Maryland and Virginia are getting ready to do XD data as well. So just those 4 states, but all the other states who have access to Probe Data Suite are welcome to go in and take a look at that. We've also now deployed 2 XD signalized arterial analytics tools for PennDOT. You've been hearing a lot about these at the past 2 different user group meetings, but those are now live and deployed and available for use. There's some new dashboard widgets that we've deployed and a few other enhancements, including the Region Explorer. The Region Explorer now doesn't require the Flash player anymore. It's been modernized. There's been some major enhancements to bottleneck ranking algorithms and other stuff that we've done. Let me jump in and show you some examples of these updates. First is with the XD data. When you're using the tools now, you can go in, and the first option that you'll see within some of the tools is choosing between TMC segments or XD segments. If you want to see the XD data, you got to click this little drop-down button right here and switch that over to XD data. And here's just an example of what some of the charts can look like. They really don't look much different than they used to do, except they might have finer granularity associated with them, but the outputs haven't changed significantly. You can see some pretty big differences, though, when you're looking at congestion scan, for example. So here is I-81 southbound in Pennsylvania. The rightmost graph is what the congestion looked like using regular TMC segmentation. So you can see a big TMC segment right here and then some smaller ones backing up. This is for one day. Over on the left-hand side, we're able to see the XD segmentation shows those big TMC segments broken down into some finer granularity, which lets you see the growth of this queue a little bit better over time for that one day. We've also deployed the XD travel time comparison tool for looking at signalized arterials. Again, this is based off of the Purdue tools that allow you to go in and choose a corridor with a lot of signals, choose a before date and an after date, and see if you're improving travel times and reliability on your signalized arterial corridors. And this also allows you to overlay where your signals are to actually see where you might have some timing issues on those particular corridors. The XD Delta ranking tool has also been deployed. This tool, again based off of some of the Purdue signal performance measures, allows you to choose multiple corridors in a state or a region and essentially rank all of those corridors in terms of which ones are improving in terms of travel time reliability or getting worse or getting mixed results. There's all sorts of different visualizations and statistics that tell you which corridors are performing better or worse than others, so you know where you need to focus your resources. Some other significant enhancements: bottleneck ranking algorithm and hardware improvements. We just deployed some brand new hardware for all of our bottleneck ranking algorithms, which is going to speed up the results. But we've also made some enhancements to the algorithms. One of those enhancements deals with how to handle missing data. So in the past, when there was missing data because of a network outage or something, or just a TMC failed to provide data for that segment, then we didn't handle that terribly well or didn't quite know what to do with it. Now we've built in some basic imputation functions that will go in and process the data and fill in gaps where they exist so that the bottleneck ranking algorithms are better. The results are better. You will see some results, some changes in results you may have run in the past, but we anticipate this would significantly improve those results. But let us know if you see anything concerning. I mentioned this already, but we also enhanced the Region Explorer. It now uses more modern web technologies, doesn't require the Flash player anymore. Still pretty much looks and acts the same, though. Then we have a new dashboard widget that's been deployed. This dashboard widget allows you to go in and choose a region. It could be an entire state, it could be a county, it could be whatever you want, and it will tell you what this month's top 10, top 20, whatever bottlenecks there were, and the location of them, and then it shows you for the past X number of months how that ranking has been changing over time. So is this month's worst bottleneck, is it always the worst bottleneck, or has it been changing, getting better, getting worse over time? This dashboard widget now exists. Feel free to go play around with that. We've also made some updates to the Npm Rds tools, which if you're using Probe Data Analytics, you should have access to these tools as well. One of them is we've been updating the conflation, and not just updating the conflation shapefiles, but giving you the ability to see what the changes were between the two different conflations. So you now have the ability to select which conflation you want to use. Do you want to use the 2017 conflation or the 2018 conflation? And this makes it easier for you to see what's changed. So you could choose a particular road and the 2017 conflation, and choose the same road and select all the segments from the 2018 conflation, and you'll see how many segments there are and see if any were added or removed between those conflation efforts. And then you can also display the coverage and conflation within the Npm Rds coverage map. There's a new drop-down in the right-hand side that lets you switch back and forth between 2017, 2018, and see what's changed. Now, I think these next few slides are perhaps some of the most important slides we're gonna cover. So if you haven't been paying attention up until now, please start paying attention. When the Vehicle Pro project started way back in 2008, 2009, INRIX donated a national volume data set to all of the Coalition Probe Data purchasing members. And they worked with Texas A&M to create this data set. It was great. It was a one-time donation, and that volume data has been used by most agencies for the computation of the user delay cost calculations. Now, except for one or two agencies, Michigan and Virginia, most of the other agencies that are using Probe Data Analytics Suite have not been providing the University of Maryland with updated volume data every year. So why does this matter? Well, volumes naturally change over time. You might have more people out there. You might have less people out there. The other issue is that TMCs get retired. So some TMCs might just cease to exist each time a map is updated. And new TMCs are added to increase coverage. So that's a good thing. We want the maps to get better. We want there to be new TMCs. but that does produce a problem. And that problem deals with how the number of TMC segments change over time and how that affects volume. Looks like my graph is not showing up here. Go back. All right, something has happened to my beautiful graphic there. But essentially what's happening is over time, the number of TMC segments that exist have been going up. You've got lots and lots of more TMCs that are being added to the data set, but there's fewer TMCs then that have volume data associated with them, and the gap between those two numbers is growing significantly. That means that some user delay cost reports in certain states have been getting less data behind them over time. And this really needs to be addressed by each agency. So there are some things that can be done about this. The first is that you can start providing your own volume data to us, and that's what Michigan and VDOT and Maryland have been doing. And we've got some documentation up on our website that tells you how to do this and how it needs to be formatted so that we can drop it into the system for you. You could also have us replace the old volume data with the volume data that's now coming from the Npm Rds HPMS conflation exercise. That said, that's not going to fix every problem. And the Npm Rds volume data only covers the national highway system, so a lot of your arterials might not be covered properly. The coalition is also working with researchers at UMD and NREL on a volume estimation project to produce higher quality volume estimation than has been available in the past. Doing this for your state would require some funding and some pretty substantial coordination, as it's a data-intensive effort. We have to go in and look at weather data and geometries and incident data and all sorts of other stuff, but that can be done. You could also potentially work with your probe data provider to get new volumes, but that's probably ultimately going to cost some money as well. The point is, we need agencies to start providing updated volume to us, and there's options, and reach out to us further so that we can work with you on how to get updated volumes into the system. Let me pause for just a second and see if there's any questions that have come in that I need to address.
Hey, Michael, it's Jesse. Yeah, it does look like we have some questions, some of which have been addressed, but I think may be worth repeating. I'm going to kind of go up a little bit to the earlier questions. We had one from BG Ding of the City of Atlanta, just asking about in RITIS, can you select local roads too, and how reliable is the data on local roads, and have they been validated? And Zach answered that the off-freeway efforts so far have focused on high-functioning arterials, but that they're increasingly looking to validate along different facility types, and some recent arterial reports have included lower ADT roads, but we haven't been focusing specifically on those yet. I know at DVRPC we've been using data on some of the lower volume roads in our region, and I'm sure other folks are very interested in that as well. So I don't know if there's anything you want to add there, Michael.
I don't think I have anything else to add to that.
Okay. Then Enoch was asking about whether agencies have to pay to get access to XD, and Rick Schumann from INRIX recommended, he said that any agency that has an active data license with INRIX, for example, through the Vehicle Probe project, could include XD data in the PDA suite tools that Michael just reviewed, and he just recommended contacting either himself or Michael to figure out, what might be required.
Yeah, the main thing is the XD data is 4 to 8 times the size of a regular TMC data set because there's just so many additional segments. So for the university to archive that data, include it in the probe data analytics tools, we need to increase our data storage costs a little bit. It's not a significant amount of additional funding, but it does cost us a little more. So yes, each state would have to reach out to us to get the pricing to start archiving that for you.
Yeah, thanks for clarifying that. I think it's good for everyone to understand that it's a lot of data. So thank you for the work you're doing to archive it and make it available to us. Another question that came in that I don't think has been answered yet from Youngwook Yoon. Can you provide TMC level delay measures? So for example, when they select I-95 right now, you can only have a single delay for an entire corridor, and just wondering if it's possible to have TMC level delay measures.
So I assume what you're wanting to look at is, instead of choosing all of I-95 or a bunch of TMC segments, you want to see delay per TMC segment. Is that what you're asking for? I'll let you type. Yes, okay.
Yep.
So that is something that's doable. Right now, you would have to literally go in and choose each individual segment and run a user delay cost report, and we understand that that is a pain. The goal would be to almost create like a congestion scan tool where we would show you user delay cost for every segment, for every hour of the day. That is something that we are looking to develop, but it is not something that is going to be done, next week or next month. There is an API that we have that would allow you to programmatically ask for user delay costs for individual TMC segments, but it would then just return the raw data, the raw user delay costs back to you, and you'd have to visualize that through your own means. So that is an option, but visually we don't have that available today. And if you could send me an email, I'll type in my email address down here, and we can have a longer discussion offline about what you think the results should look like, how they should be formatted, so we can make sure that what we're going to work on is going to suit your needs properly.
Okay, and then one last question to cover here. Ira Levinson from NG.dot had asked if XD segments are shorter and more complete than TMCs, and Rick Schumann had answered that in general, yes, there is both an increase in coverage and segment granularity. The specifics depend on the region, obviously, and in general, he mentions that Purdue's research has found that XD segments were far more suitable for arterial validation than TMC segments. And I've looked at a little bit for the DVRPC region. I think in our region, we have some challenges because we have a lot of, unique, interesting intersections. So, it ends up resulting in some very short segments at times, and I think that's just something you sort of have to keep an eye out for, and maybe, develop some, standard ways to, look at those segments when they're, sort of too small to make sense from a data perspective. So I don't know, Michael, how much you've delved into that yet, if you have any other tips or advice, or, I'm sure that'll be kind of an emerging area of research.
Yeah, it's definitely something we're still looking at. We tend not to study those as much as other universities do. We build the tools that help those other universities study those things.
Well, if anyone else has questions, and thank you, Michael, for answering all those, I guess I would recommend, especially if people have questions about the volume data that Michael mentioned, now would be a good time to enter those in. Definitely an important thing to start getting better, more recent data there.
Yeah. I'll keep going while more questions come in, and we can stop a little bit later.
Sounds good.
All right, so there's additional work that's in progress right now. The Everyday Counts tool that I showed you earlier in a live demo, even after we deploy that next week, there's still some additional features and functionality we want to build into that, so you'll see those tools strengthen and get better over time. we're now shifting our focus to the bottleneck ranking tool. It still requires Flash, and it's one of the last tools that we have to migrate away from Flash so that you don't have to use that anymore. Detector analytics modernization, we're also migrating away from Flash for that tool. And then there's a couple of more dashboard widgets that we're building into the system. I showed you the bottleneck ranking dashboard widget earlier. We also have a user delay cost dashboard widget. We're now working on a reliability widget that will show you how the reliability of different roads is changing over time. And then also some incident and event comparisons. Dan Smith earlier showed us some really cool dashboards on his big video wall that showed how many incidents their agency has been responding to this year, and he mentioned that they had hit over 100,000 last year. We're going to build some similar dashboard widgets into the RITIS suite. So if other agencies that can't already do that with their video walls want to, they could use our tools on their video walls to display incident and event comparisons over time. And then also we're working on some MAP 21 Npm Rds enhancements, and I'll explain that here in just a second. So we have these deep dive analytics tools for looking at the Npm Rds data, and we've had a lot of requests to enhance those tools to make some of the MAP 21 calculations not just easier, but easier for figuring out what your target should be, and easier for doing other types of analysis that's going to support your MAP 21 reporting over time. So some of these are pretty basic. So mixing peak periods for UZAs, that is something that is actively being worked on right now. Offering sub-UZA selections if you're looking at like a multi-state UZA. So think about DVRPC in Philadelphia, New Jersey. Maybe they want to look at the performance of their UZA just in Pennsylvania or just in New Jersey. They don't want to look at the combined. Also building in some sensitivity analysis into the tool to try to give you some information on which segments we believe are most at risk of hurting your MAP 21 performance in the future, or which segments are the best ones to focus on in terms of improving performance. So look for that in the future. Also building some other non-standard reports and doing MAP 21 reporting on non-NHS segments, so other TMCs beyond the NHS system. And then some other reports and visualizations. We'll probably be putting together a little working group and providing some mock-ups of these tools before we go out and deploy them. But look for that in the next user group meeting for sure. So with that, every single thing that I've shown you thus far, every piece of functionality that we're building is driven by you, the states and the MPO users, and university users as well. You're always welcome to join any of our user groups, our working groups, our listening sessions to help us brainstorm and refine these new features and functionality. And really these tools only get better if you're telling us what you don't like or what you need. So we need you to be audible. We need you to tell us not just what's working, but what's not working for you. And so this is the point during our meeting where we just kind of open up the floor and we listen to you. So this is your chance to rant at us for a while. And I'm going to remain silent to allow things to come in.
Thanks, Michael. So yes, encourage folks to rant, to share any challenges, frustrations, successes, whatever it may be. Definitely looking forward to the tool that Michael just mentioned in terms of identifying, some of the best segments to address in terms of the performance measures. I know we're starting to work toward, we have, transportation improvement programs need to have some discussion of how you're addressing your performance measures. So, this will be really helpful as we're developing kind of text to explain, what these performance measures are and how we're working to address it in the Philadelphia region. So we did get a couple of questions relating to some previous presentations, so maybe as we're waiting for more comments to come in, we could look at those. Kelly had asked which EDC project that the tool you've developed goes with.
So the Everyday Counts tool is embedded in RITIS proper because it deals mainly with incident and event data. It doesn't really deal with probe data specifically. So it's just a part of the standard RITIS suite.
Okay, our next question came from Catherine Tully. She's asking if INRIX provides any sort of TMC XD segment crosswalk. I guess that might be one for Rick Schumann, or I don't know, Michael, if you're aware of anything there.
It looks like Rick just answered that.
Oh, okay. So yes, Rick says that they can do that. It does require a little bit of an additional fee to license data from their map provider, but it can be done. Usually can. And then Ira Levinson was saying that the bottleneck ranking tool gives you an Excel spreadsheet with lots of large numbers, but it doesn't necessarily have definitions of what the measurements are, such as time, distances, and other measures that might be applicable.
So Ira, that's a good point. I think we have that in our help files, but are you saying that you think it would be better if when you got an Excel download that there was a README file, a metadata file that came along with it or something like that? I'm guessing that's what you're looking for.
Yeah, I think that's usually helpful, and it looks like Richard Rabinowitz is kind of echoing that comment that it's always helpful when tools explain what's being reported. Sometimes it might seem as if it should be obvious, especially to the people who created it, but something like a README file probably would be quite helpful.
Mm-hmm.
Even if it's just available on the website and you could download it if needed. Another question came in from Mohammed Kadumi asking if choosing an MPO could be an option when selecting a region in the PDA suite, similar to how you can do that for the Npm Rds measures. Is that something you're looking to integrate?
Absolutely. We've had several people ask for that, and that's something we're working on.
Great. Yeah, especially for us 9 county MPOs out there.
Of course, it's not going to, that option isn't going to make sense for something like the congestion scan, but, for certain tools, having an MPO selection would make sense for certain.
And then Kelly had a comment that we still spend a lot of time manually combining overlapping bottlenecks before they use the bottleneck ranking tool, at least in North Carolina. And she's wondering if anyone else is doing anything like that. And Kelly, I don't know if you want to maybe elaborate on there, or I guess maybe you're not set up to talk here. But yeah, so if anyone else out there is having a similar process, go ahead and enter something in the chat pod there. While we're waiting to see if any, looks like Kelly's typing. In the meantime, Jerry Sneed has a question. Could you expand on the vision of TADS?
Yeah, so
ADS, and what is that?
Yeah, that's Transportation Disruption and Disaster Statistics. So we're going to have a separate meeting on that a little bit later. But essentially, I think everyone probably is familiar with the congestion pie chart that Federal Highway put out, 14 years ago probably, that said approximately 50% of the congestion that's out on the roadway is non-recurring congestion and attributed to disabled vehicles or weather or collisions or other types of events, something like that. So that congestion pie chart has been used by a lot of people to make some pretty important investment decisions over the years. And it was based largely on model data, and it's one congestion pie chart for the entire United States. We believe that there is enough data available now to be able to produce this congestion pie chart using real data, not model data, and doing it for not just the entire country, but for individual states, individual counties, individual corridors. So imagine being able to go in with your state and say, I want to look at my congestion pie chart for the last 3 months. How much of the congestion was out there was related to weather versus collisions versus work zones? What was the expense of that? How's that congestion pie chart been changing over time? How does the congestion in my state compare to other states in terms of cause of congestion? Because Florida shouldn't have any winter weather congestion, but Maine certainly does. And being able to look at those differences over time and having better data and better tools to justify your investment decisions and your operations programs moving forward is really what we're looking for. So it's a year-long project, and it really just kicked off within the last week or two, and there will be a steering committee made up of coalition members. Denise Markow is leading that, and I think she's going to talk about that maybe in some of her closing remarks as well.
Wait, Michael, I was going to hit that at the end. Do you want me to hit it now?
I think we're about to get to you, Denise, so
Okay.
Looks like we're running out of time here for the agency input session, but want to thank everybody for a lot of great input, good conversation, and looking forward to the development of that tool. I know I've always been a little suspicious of those numbers because of the reasons that Michael mentioned, being nationwide, different areas are very different. So I really look forward to having that data for our region. So I think with that, as we're getting close to the end here, I'll turn it over to Denise to wrap things up.
Thanks, Jesse. To circle back on the discussion with TDADs, as we call it, I will be doing some outreach, and Michael's as well, for folks that might be interested in being on the steering committee. And the goal of that is to keep you involved and integrated in the design of this tool to make sure that we're working with it and developing in a way that you all will be able to use it. So look for an email. If you're interested, please email Michael or myself and say, yes, please, I'm interested. We'll provide you with information. But right now we've just kicked it off. We're in the process of doing some framework design, and then we anticipate having a kickoff meeting with the steering committee just to introduce you all to what is involved. And with that, I think I can't say enough about the conversation. It looks like it's been great. We will make sure that there is a Q&A. We capture the Q&A, and we'll provide that as well as the slides and the audio on the website. So with that being said, thank you to all the presenters. You guys did great. And Michael, thank you, as always. Good stuff. Jesse, you did an amazing job as a facilitator. You're hired. Anything else? I think we're good. And we're right on time. We're at 11:58.
Denise, I think you wanted to mention the Coalition's new YouTube channel.
Oh, I did. Thank you very much. This is a new slide we just put on. The Coalition has a YouTube channel. This is where you'll be able to find some of the audio presentations for our webinars, so please check it out. It's just really new, and this presentation will be up there when you get a link and information when we're all set with the Q&A and the slides and the presentation and audio. Okay? Thank you, Joanna, for reminding me. All righty, with that being said, everyone have